Okay, Royals. For lesson 3.4, I just have a short conversation that I want to have, and that's again to emphasize what my expectations are of you. Our curriculum says we should be able to use limits to determine end behaviors of functions. Our textbook mentions using limits as an approach to find equations of asymptotes, but we have already demonstrated an understanding of a course called Advanced Functions where we know more efficient ways to do this. The limit provides a programmable way for this to happen, and that is very important, but I don't plan on asking you to use a limit. What I should be able to do is just give you a couple of fill in the blank questions, or these make pretty good multiple choice questions for some sort of culminating evaluation. Okay, let's try these two out. If you're feeling comfortable with these, then you're in pretty good shape. And I wouldn't suggest that you need to practice evaluating these behaviors using limit strategies. Okay. If f of x is 4x plus 3 divided by 7x plus 1, I don't need to remove a factor of 4x. I don't need to multiply by the reciprocal of x to see that as x grows without bound, these constant terms become negligible. And 4 times a million divided by 7 times a million is going to be about 4/7. So as x grows without bound, my function values should converge on 4/7. That's telling me that I'm uh, expecting a horizontal asymptote of y equals 4/7. Okay. Talking about the degree of the numerator and the denominator isn't going to be as useful in a calculus class because we will have to look at functions like f of x equals x divided by the sine of x. Does this function have a horizontal asymptote? Well, I don't know. Let's look at the degree of the numerator and the degree of the denominator. Uh-oh, the denominator is not polynomial. Well, I guess that old trick isn't going to work anymore. So make sure you understand why there's a horizontal asymptote here, not that you've just memorized. If the degree of the numerator is the same as the degree of the denominator, then you're going to have a horizontal asymptote in the format of the coefficients of, or the leading coefficients of the numerator to the denominator. I mean, I wrote the worksheet. I just don't think that you should memorize it. Okay, g of x. We have g of x in a division format. And just read the directions carefully. I mean, I shouldn't have to put on a test, read the directions carefully, because then students probably wouldn't read those directions carefully. Yeah, this isn't a little typo. This isn't just a smudge on the paper. Here we're asked, how does the derivatives, how do the derivatives values behave in the long term? So let's talk first about the function values. As x grows without bound, this expression becomes negligible, which means that my function is going to approach the same values as 2/3 of x plus 1. What we have here is an oblique asymptote of y equals 2/3 x plus 1. Okay, we're always going to be a little bit different. When x is close to 0, we're going to be a lot different. But as x gets further and further from 0, this becomes negligible, but we'll always see there will always be a small difference. Not always seeing it, that's a contradiction of the term negligible. But which means our function is going to behave more and more like this linear relationship, which means that our rate of change should be approaching the constant rate of change of the oblique asymptote. And the rate of change of the oblique asymptote is going to be 2/3. So we don't need to use derivatives. We don't need to use limits here. We should be able to reason through this and say the rate of change of the function is going to converge on the rate of change of the oblique asymptote, which in this case is going to be 2/3. Okay. Be ready for questions like that. Sort of fill in the blank, demonstrate your understanding of this fact instead of using limits.